Welcome back, one and all. So this is the module 3 we had started, fast Fourier transform. So far we have seen the need of FFT. So we started our journey from DFT and we checked the 4-point DFT and some numericals we had seen. So after that we had found out what is the advantage of FFT over DFT. So what we found was FFT is using very less number of calculations to find the DFT of the sequence given to us. Though the results are same, but FFT does it with a very less number of calculations. So computational efficiency is the main advantage in FFT. We had seen what is called as butterfly structure. We had seen what is meant by radix 2 DIT FFT. So DIT is decimation in time. There are two algorithms, DIT and DIF. So as far as our syllabus is concerned, we are only supposed to use DIT algorithm for FFT. And we have seen what is meant by butterfly structure. So we had started from radix 2 DIT FFT, that is 2-point, 4-point, and 8-point is remaining. So today we will see that. So far we have seen the need of FFT, the FFT algorithm, what is meant by radix 2 DIT FFT, and some numericals and theory of 4-point DIT FFT. So today's topic is mainly one more numerical we will do on DIT FFT for 4-point, and then we will see the large part or most difficult part, as students say, that is the 8-point DIT FFT. It is not difficult. Only thing is you have to draw the diagram, so you have to practice it quite a few times, and once you master that, it's a very repetitive kind of a process. So given any sequence, discrete sequence of length 8, you can find what is the DFT through FFT algorithm, that is the DIT FFT algorithm. So before going for 8-point DIT FFT, let us have a small recap of 4-point DIT FFT. So what main thing is a xn sequence of length 4 will be given to us. So x0, x1, x2, x3. So input side we have to do it in a rearranged form, that is called as x0 and x2. The even part should be at the top and the odd part should be at the bottom. So be very careful about it. So for DIT FFT, input is in a rearranged form and output is in a properly arranged form, that is x0, x1, x2 and x3. And there's a twiddle factor, w40, w40 is 1, and here w40 is 1 and w41 is equal to minus j. We have seen how to find all this. So w is nothing but the twiddle factor, e raised to minus 2j pi nk divided by capital N. So that is what we had found. W14 means 2 e raised to minus 2j pi divided by 4. And we have seen how to find the values of different twiddle factors. So what is the first step? So there's a 2 there's a 2-point DFT in the initial stage. So x0 and x2 is there. So one link goes up, another goes down, and this minus 1 is a very important factor. So in 4-point DIT FFT, there are 4 number of minus 1. So positions of all these things you have to remember. And there is one minus j and there is one 1. Okay, so this numerical we had seen, that is sequence given to us was 2 2 3 1. So we had found out, so this is small x0, small x1, small x2 and small x3, and output is given by capital X0, capital X1, capital X2 and capital X3. So the input side is discrete time domain in n and output side is discrete frequency domain in k. And you can check that the input is given by small x, output is given by capital X. Now first we are supposed to segregate the even and odd part. So 2 and 3 are at the top part of the 4-point FFT, and 2 and 1, so this 2, that is x1 and x3, they're at the bottom part of the table and bottom part of the algorithm. Then after the stage 1, you can just check. So this 2 and 3 get added and it becomes 5. So this 2 comes below and this 3 becomes minus 3, that gets multiplied with minus 1. So this is 2 minus 3, that is minus 1. And again here at the bottom part, so this is 2 plus 1 3, and bottom part 2 minus 1, that is equal to 1. And after that, all this stage 1 output are getting multiplied with the twiddle factor below. So at the top there is no twiddle factor, So this 5 is 5 ready for the next stage, minus 1 is minus 1. This 3 comes here, and this 1 actually gets multiplied with the total factor of minus j. So this 1 into minus j becomes minus j. So this is the output of the first stage. Output of the first stage is to be multiplied with the total factor, and then they are the input for the second stage. And in second stage there are 2 minus 1. So incorporate very simple addition and multiplication kind of thing, and you are getting x0, x1, x2, and x3. So this 3 goes up, and this 5, so 5 plus 3 is equal to 8. Minus j goes up, and minus 1, so it will be minus 1 minus j. Now this 5 comes down, so direction of arrows are important. So 5 comes down, and 3 and minus 1, so minus 3. So x2 becomes 5 minus 3 is equal to 2. And finally x3 becomes, so this minus 1 comes from the second line, and this minus j is multiplied with minus 1, so this becomes minus 1 plus j. We finished here last day. Let us have another new numerical. So step is same. Only thing is I have given you a 2-point sequence xn. So input sequence is now having only 2 points, 1 and 2. And what is asked is you are supposed to find 4-point DFT, or somebody can ask you to find 8-point DFT for this. So don't get confused. So what you are supposed to do is this is a 2-point sequence. First you have to make it 4-point sequence. How can you make it a 4-point sequence? Just add 2 zeros here. I'm sorry, so I'll just make a small change. There will come a bracket. So now this bracket is very much important. So given was a 2-point sequence 1 and 2, but I have asked you to find 4-point DFT or 4-point FFT. What? So first what you have to do is you have to convert this 2-point sequence into 4-point sequence. For that we can add 2 zeros here. By giving the same 1 and 2, I can ask you to find out 8-point DFT. In that case, you have to pad 6 zeros afterwards and make the sequence as 1, 2, and after that 6 zeros, and then you can find 8-point FFT for the same. So now what we find is x0 is 1 and x2 is 0. So that is what I have written. Even part, x0 is 1 and x2 is 0. And next here x1 is 2 and x2 is and x3 is 0. So x1 is 2 and x3 is 0. And the same part now, so this 0 plus 1 is equal to 1, so you have to do this. So this 0 goes up, and this is 1, so 1 plus 0 is 0. And next is this 1 minus 0, so this is again 1. Next step, 2 plus 0 and 2 minus 0, so this is 2 and 2. This is the output of the stage 1. Then this 2 is getting multiplied with 1, so it becomes 2 here. This 1 and 1 goes forwards. Only difference is this 2 gets multiplied with minus j, total factor. So this minus j minus 1, sorry, minus j 1 and x0, x2, x1, x3, all these are part of total factor, part of the 4-point FFT algorithm. And this minus 1 minus 1, so there are 4 minus 1s, okay, in the bottom part only it is existing. And all this comes from that famous Cooley-Tukey DIT FFT algorithm. So there's the input to the stage 2. So stage 1 is only 2-point FFT, stage 2 is 4-point. So you're mixing all the signals available in the algorithm. So now this 1 are staying here, this 1, this 2 becomes 2, and this 2 becomes 2 into minus j, that is minus of 2j. And now what is the output of the second stage or final output? This is 1 plus 2. So first stage x0 is equal to 1 plus 2. So this is 1 and this is 2, this is 3. And next stage is 1 minus 2j. So this is 1 minus 2j. So minus 2j comes from below and 1 comes here. So this is 1 minus 2j. x2, nothing but 1 comes from top and 2 comes here, but 2 gets multiplied with minus 1. So this will be 1 minus 2, that is minus 1. And again this 1 comes from second line, and this minus 2j gets multiplied with minus 1, and it will become 1 plus 2j. So these are the output. Now things to observe. Things to observe is the first line is nothing but the addition of all the components in xn. Okay, so xn is having 1 plus 2 plus 0 plus 0. So this is 1 plus 2 plus 0 plus 0, that is 3. This is the DC component or strength of the signal. And remaining 3 are the frequency level components. So this x1 and x3, they will be complex conjugate. So x1 is 1 minus 2j and x3 is 1 plus 2j. So if you are able to calculate x1 properly, if you are confident about that, you won't even have to calculate x3. Directly you can write down x3 as the complex conjugate of x1, and x2 will nothing but minus 1. So this is the same numerical as we had seen in the previous case, but only difference is there is a small trick used. That is, I have given you a 2-point sequence and I'm asking you to find a 4-point FFT. So the trick is you have to add, or you have to pad rather, two zeros and make the sequence as a 4-point sequence, and then perform the same algorithm which we had found. So the same result you can find by the matrix method, which was shown to you previously. So I think you remember that. So this is the kind of a matrix. So if you substitute here, instead of x0, x1, x2, x3, if you substitute here 1 2 0 0, and if you substitute here 1 2 0 0 and multiply this by this 4-point DIT FFT matrix, then also you are going to get the same result as whatever you are getting. That is 3 1 minus 2j minus 1 and 1 plus 2j. Whatever we have just now got, the same result will come here. So only thing is, this matrix will remain same. This is the 4 by 4 DFT matrix. Instead of the signal, you have to write 1 2 0 0. That's all. So you can validate all the FFTs or all the DFTs by means of this 4-point matrix, whatever is given. For 8-point also such matrices are available, but generally we don't do 8-point by the matrix method. In that case, huge amount of calculation will be involved. So this is actually the highest level of difficulty for your syllabus as far as FFT is concerned. What we find is I will be giving you a 8-point sequence, that is x0 up to x7, and I'll ask you find what is the 8-point FFT for the same. So 8-point DFT and 8-point FFT result will be same, only the method will be different. So what we have to do is the input side, it will be a reversed format, bit reversed format. So this is x0 and x4. This is the first thing. So this sequence you have to remember, x0 and x4. Then there will be x2 and x6. Okay, so this is the top half, which is the even part. And even part also, it is not x0, x2, x4, x6. It is x0 and x4. So always there is a difference of 4 between all this xn sequences. Okay, so this is x0 and x4 at the top, then x2 and x6. This is the even part, and bottom part, this is x1 and x5 and x3 and x7. So this is the groupings, and this reversed form you have to remember. So this is x0, x4, x2, x6, x1, x5, x3 and x7. Now the stage 1 we have already seen. So this is the butterfly structure of for two inputs. The same thing, the -1 comes below, and here also -1, here also -1, and here -1. So there are actually 12 -1s in this 8-point DIT FFT algorithm. So every stage is having 4 -1 multiplying factors, and every stage is having actually 4 twiddle factors as well. So a lot of books, they will not write this twiddle factor because W80, this is having value of 1. That's why this W80 are not written, but this W82 is there, and second stage. So this up to this part, okay, whatever is shown above, this part actually is a 4-point DIT FFT numerical. So whatever is the upper part, this part already we have seen in the previous two numericals. Exactly same thing, there is no difference. And W82 also is equal to -j, that is same as W41 twiddle factor. So two such 4-point DIT FFT numerical you have to do first, and then you have to mix the result of them after multiplication of this 4 twiddle factors. Okay, so this multiplication is where students are making maximum amount of mistakes. Okay, because you can check that this 8 related, so W80, W81, W82 and W83, these twiddle factors are little big, so you should be good in operating calculator, and you should be good in finding out the complex multiplication, that is a plus jv into c plus jd kind of a multiplication. You should be able to do properly by using calculator, or hand calculation also will do, but this is not difficult. Only thing is this is cumbersome and this takes some lot of time. But 2 3 numericals if we solve, it will make us perfect, and results are quite predictable, because here if you are seeing the results are x0. So x0 is nothing but whatever input sequences are given, you just add them together, you are going to get what is called as x0, which is nothing but the DC component. And then you are finding x1. Okay, this is the frequency level component, this is the x7. So x1 and x7 will be complex conjugate. Similarly, x2 and x6 will be complex conjugate. X3 and x5 will be complex conjugate. So if you are able to calculate, x0 is calculated very easily, that is addition of all the symbols. X4 is the central component in the spectrum. So x4 is nothing but plus minus of all the input sequence given, that is x0 minus x1 plus x2 minus x3 plus x4 minus x5 plus x6 and minus x7. So this way you can find out x4 very easily. So x0 is found out by adding all the components, x4 is found out by alternate plus minus of all the components. So two things are done. Only you have to find out x1, x2 and x3 correctly. Okay, and if you are able to find out x1 and x7, they are complex conjugate, x2 and x6 they are complex conjugate, x3 and x5 they are complex conjugate. So actually speaking, you have to really calculate only these three things, x1, x2 and x3, by using all this complex method. X0 and x4 calculation is very easy. So if you can calculate this five, remaining things are quite easy. And among this five also, x0 and x4 is calculated very easily just by addition and subtraction. So this is more or less the structure of 8-point DIT FFT algorithm. W80, you can check here. W80 is 1. W81, so be very careful. W81 is 1 by root 2 minus j by root 2. So 0.707 is nothing but root 2. So this is 1 by root 2 minus j by root 2. W82 is minus j. W82 is same as W41. Okay. So this is equal to minus j. Again, very easy. And W83, that is minus 1 by root 2 minus j by root 2. Okay. So this W81 and W83, they are not complex conjugate. Be very careful. Okay. W83 and W85, they are complex conjugate. W81 and W87, they are complex conjugate. W82 and W86, they are complex conjugate. But here we are supposed to use W81 and W83. They are not complex conjugate because W81 is 1 by root 2 minus j by root 2. W83 is minus 1 by root 2 minus j by root 2. So only this upper part thing you have to know. So only difficult thing is W81 and W83 and the multiplications by them. So if you check that there are 8 lines, this this sixth and eighth line multiplication is the main point where students are making mistakes. So be careful. So this line, there is a sixth line wherever W81 is there. That means whatever comes at this point, you have to multiply this with 1 by root 2 minus j by root 2. And whatever comes here, you have to multiply that with minus 1 by root 2 minus j by root 2. So these are the two difficult things mainly where students make mistakes. Let us take a numerical. This is the only numerical we will solve today. More numericals I will be solving in the next session. So let us just check one very simple sequence is given, discrete time sequence, which is 1001 0000. Okay. So this is x0, this is x1, x2, x3, x4, x5, x6 and x7, and whatever output will come, that we are supposed to find out by DIT FFT algorithm. Again, you can check here. First is they are having minus 1, minus 1, minus 1, minus 1. So there are 4 minus 1s in the stage 1. There are 4 minus 1 in stage 2, which is nothing but the 4-point FFT. And there are 8-point FFT. So mixture of all lines that happens in the stage 3. Okay, so this is the algorithm. This is the structure you have to fit into your mind. By practice, very easily you can master it. And what we find is students are doing it very perfectly in the exam, those who are practicing. So you won't have to panic. Only thing is the twiddle factors you have to remember. So this W80, W80. So generally people are not writing it. So this first stage of twiddle factors, because all these values are 1. So they are generally writing twiddle factors after the first stage or at the input of the stage 2. So this is W80, this value is 1, and W82 or W41, same thing, this is minus j. Okay, so whatever you find up to stage 2 output, this is already you have done in case of 4-point FFT. So this W82 is minus j. Here also the same thing, W80 is 1 and W82 is minus j. Main change comes here, be careful. This is the output of the second stage. Here W80 is 1, W82 is W41, that is minus j. W81, okay, as is given in the previous slide, it is 0.707 minus j 0.707. So I am writing it 1 by root 2 minus j by root 2. And W83 is minus 1 by root 2 minus j by root 2. And W81 and W83, they are not complex conjugate, because here the real part is positive, here the real part is negative. And in both cases, both the imaginary parts are negative. So be careful, W81 and W83, no relations. They look similar type, but they are not complex conjugate. Now let us arrange the first initial part, that is time domain signal. So first is x0 and x4. So x0 is 1 and x4 is 0. So this is x0, that is 1. X0, x1, x2, x3, x4, x4 is 0. Then x2 and x6, so you can find out this is x2 and this is x6, both are 0. Then x1 and x5, so this is x1 and this is x5, both are 0. And x3, so this is x3, this is 1, and x7, that is 0. So input side, this is 1001 0010. This is in the reversed form, whereas the actual signal is xn 1001 0000. Be very careful, don't write input to the FFT as 1001 0000. That does not happen like that. It happens in case of DIF algorithm, that is input is in a properly arranged form, that is DIF algorithm. But what we are doing is DIT algorithm. In this case, the input is rearranged form or reversed form. Okay, so the x0, x4, x2, x6, x1, x5, x3, x0. This you have to arrange in reversed form, and then calculate this butterfly structure. So if you're doing this butterfly structure at the output of the stage 1, what you're finding, just check here, the output of stage 1 is given. So here the 0 goes up, okay, so this is 1, so 1 plus 0 is 1, and this 1 comes down, so 0 minus, so this is also 1. Same here, here both the inputs are 0, so output is 0. Here also both the inputs are 0, output is 0. And in this case, x3 is 1 and x7 is 0, so output is 1 1. So there is nothing to understand as such in this step, only you have to follow the arrow, you have to do the multiplication and addition. After that, what happens, the output of stage 1, they are multiplied with the twiddle factors. So this top two line, no twiddle factor. Third, fourth line, they are having twiddle factors. Line fifth and sixth, they are not having twiddle factor. And line 7th and 8th, they are having again twiddle factor. So mainly if you check line 4 and line 8, they actually are affected by the twiddle factor multiplication. All other lines, the twiddle factors are 1. Okay, so if you're just multiplying this, what you'll be finding is, so this 1 1 0 0 0 0, they stay the same. Here the 0 is getting multiplied with minus j, hence there is no change compared to the output of stage 1. So if this was 0, this is also 0, and big change comes in line 8. So this was 1 and multiplied with minus j, so this becomes minus j. So these brown lines are output of stage 1, and these green things are input of stage 2, and between them there is the twiddle factors that you have to consider. And in the twiddle factors, this minus j and this minus j, they are the main things who is changing the output of stage 1 considerably. So that we have found that this 1 is getting multiplied with minus j, so this becomes minus j. Now again do the same thing, that is this 1 is coming here and this 0 is going up, so the top one will be 1, and this 1 is coming below and 0 is coming here, so this third point also will be 1. Now this point is 1 and this point is 0, so this point will be 1. So what we find is all the top parts are 1 1 1 1. Okay, it's very simple. So just take this 0 up and 1 multiply, take this 0 up and 1, so likewise, so all the top parts are 1. What about bottom parts? So this 1 comes here and getting added with 0, so this part is 1. This is minus j goes up, getting added with 0, so this is minus j. Then 0 comes below. Now this 1 is getting multiplied with minus 1. So please don't forget to show this minus 1 here. Okay, they're very important. So this is minus 1, this is minus 1, and here there is another minus 1 multiplication, here is another minus 1 multiplication. So whenever you are calculating this seventh and eighth line, so this 0 comes here, and whatever 1 is here, this gets multiplied with -1. So 0 minus 1 is -1. In the last line, the 0 comes here, and this minus j and -1 there becomes plus j. So whatever you had found at the output of or at the input of stage 2, then you are supposed to multiply or you are supposed to perform this 4-point DIT FFT algorithm, and you are finding that the results are changing. So 1100 has become 1111, and below 001 minus j becomes 1 minus j minus 1 and j likewise. Okay. Now this are supposed to be multiplied with the twiddle factors which are given here. The twiddle factor is W80, W80 is equal to 1, and then comes W81, W81 is nothing but 1 by root 2 minus j by root 2. Okay, so these structures are unchanged. Only this input outputs will change according to whatever is the sequence given to you. Okay, so this W80, W82, W80, W81, W82, 3, all these things does not change. Okay, this is the part of the algorithm, and this -1 position also not changed because this is also the part of the algorithm. So now this 1 is getting multiplied with this 1, and here 1 will come, and this minus j will get multiplied with this W81. Okay, so this is the output of line 5 or line 6. This will get multiplied with this whole thing, and the input to the stage 3, that will become. And this is easy, so this -1 will get multiplied with minus j, so here it will be plus j, and this j will get multiplied with W83 and will come here. So let us check what is the top half. So top half, there is no problem. Whatever is the output of stage 2, that comes at the input of stage 3. Then the line number 5, so line number 5 is 1 multiplied by W80, that is 1, so this is 1. Then line number 6, so this minus j is getting multiplied with 1 by root 2, so this becomes minus j by root 2, and again minus j is multiplied with minus j by root 2, so this becomes plus j square by root 2, and j square is -1, so this becomes -1 by root 2. So this part and this multiplication you have to be careful. So minus j into 1 by root 2 is minus j by root 2, minus j into minus j, this becomes plus j square, and j square is -1, so that's why this is -1 divided by root 2. So this is nothing but the input to the line number 6 in the stage 3. Okay, this is the input to the stage 3, line number 6. Next, this -1 is here, so this is line number 7. -1 is here and getting multiplied with twiddle factor W82, and that is minus j. So -1 into minus j is plus j. Last line, j is multiplied with W83. So j is multiplied with -1 by root 2, so that becomes minus j by root 2, and j becomes multiplied with minus j by 2 root 2, so this becomes minus j square by root 2, that is nothing but plus 1 by root 2. So if you are just checking that, so this becomes j into -1 by root 2, that becomes minus j by root 2, and j into minus j by root 2, that becomes minus of j square, so j square is -1, this becomes plus j by root 2. So now this is the lineup for the stage 3 inputs, that is 1 1 1 1 1, and then -1 by root 2 minus j by root 2, j, and minus j by root 2 plus 1 by root 2. So these are the twiddle factors you have to remember. So W80 is 1, W81 is 1 by root 2 minus j by root 2, W82 is same as W41, that is minus j, and W83 is -1 by root 2 minus j by root 2. And again I'm telling you, W81 and W83, they are not complex conjugates. Please don't make that mistake, because real parts are different. For complex conjugate, only the imaginary parts symbol changes, the real part becomes same. But for W81 and W83, real parts are different. Here the real part is 1 by root 2, here the real part is -1 by root 2. Now let us calculate the stage 3 output. There is a final stage, so biggest hurdles are over. This point is the biggest hurdle, that is multiplying output of stage 2 with the twiddle factor W81 and W83. This is the biggest hurdle. Once it is done properly, this thing is almost but over. So what is x0? So now you have to go add line 1 and line 5. So line 5 input is 1, so this 1 is going up and getting added with this 1. So x0 is 1 plus 1 is equal to 2. Okay, what is x0? X0 is nothing but the DC component. how to find the DC component? Just add all the components in the sequence. So 1 plus 0 plus 0 plus 1 plus all four zeros. So you'll be finding that x0 is equal to 2. This is nothing but the DC component of the signal. This is the strength of the signal. This is not a frequency determined component. Okay, finding is very easy. Just add all the components. How do you find x4? Where is x4? X4 is somewhere here. So x0, x1, x2, x3, x4. So I'm again telling you that input is bit reversed form, okay, but output is sequential form. And this is capital and capital X, and this is small x. Okay, so this is x0. Then comes x1. How to find x1? So x1 is coming from the line number 6. What is line number 6? Minus 1 by root 2, and this is 1. So real part is 1 minus 1 by root 2, and here there is minus j by root 2. So 1 minus of this thing, that is 1 minus of 1 by root 2 minus j by root 2. This is nothing but x1. You can calculate 1 minus 1 by root 2. So 1 by root 2 is around 0.707. So 1 minus 1 by root 2 comes to be around 0.3 or something. Okay, likewise. That you can calculate by using calculator, not a big deal. Then comes x2. X2 is nothing but coming from this line. So this is 1, and this j comes above. Okay, so j from the line 7, this comes above, and there is no minus 1 multiplication in the top 4 lines. So the j only comes above, and here already 1 is existing. So this is 1 plus j. And then, so this is x2. X2 is 1 plus j. If you are confident about x2, directly x6 you can write 1 minus j, no problem. If you are confident about x1, x7 you can write as 1 minus 1 by root 2 plus j by root 2, because x1 and x7 they are complex conjugate, x2 and x6 they are complex conjugate, x3 and x5 they are complex conjugate, and x4 is nothing but plus minus of all these things, so that will come 0 here. We will see. So after that x3. So what is x3? So x3 is nothing but this 1 is coming and getting added with 1 by root 2. So this is a real part. So 1 plus 1 by root 2 is the real part, and imaginary part is minus j by root 2. So it is 1 plus 1 by root 2 minus j by root 2. This is done. What is meant by x4? So now the 1 comes below. Okay, so now no, 1 is coming below, and this 1 is coming here with minus 1. Okay, so 1 is coming from the top, and this 1 is getting multiplied with this minus 1. So 1 minus 1, this becomes 0. But directly you can calculate from here. 1 plus 0, sorry, 1 minus 0 plus 0 minus 1 plus 0 minus 0 plus 0 minus 0. Likewise, if you do, finally it will come to 1 minus 1 as 0. So calculating x0 and x4 are very easy. X0 is nothing but addition of all the terms, and x4 is nothing but alternate plus minus addition of all the terms. Okay, now x1, x2, x3 is calculated, x0, x4 is calculated. No need to calculate x4, oh sorry, x5, x6, x7. You can directly write down as complex conjugates, provided you have calculated x1, x2, x3 properly. So what is x5 will be? X5 will be 1 plus 1 by root 2 plus j by root 2. This is x5. Okay, it will be real part same, imaginary part sign change. So x5 will be complex conjugate of x3, 1 plus 1 by root 2 plus j by root 2. Check whether it happens or not. Okay, so this 1 comes from the top. Okay, so this one is coming for x5. So this one is coming here. Okay, from the top, and all this negatives are getting multiplied with minus 1. That means all this becomes positive. So 1 is coming from the top, and 1 plus 1 by root 2, this is happening here, and this minus j by root 2 gets multiplied with minus 1, this becomes j by root 2. So this whole thing becomes 1 plus 1 by root 2 plus j by root 2, whereas x3 was 1 plus 1 by root 2 minus j by root 2. So you can find out that x3 and x5 they are complex conjugate. Check about x6. So this line, third line, that is x2 line, whatever is you started with. Okay, so this one comes below, and this j comes here. Okay, and j is getting multiplied with minus 1. So this is 1 minus j. You found x2 as 1 plus j, and you find x6 as 1 minus j. So x2 and x6 are complex conjugate. Finally, x7 is in complex conjugate with x1. So the real part will be same, 1 minus 1 by root 2. Imaginary part sign will change, that is minus j by root 2 will become plus j by root 2. Just check whether it happens or not. So this one comes below, from the fourth line it comes to the eighth line, and this minus j by root 2 is getting multiplied with minus 1, so it becomes plus j by root 2, and plus 1 by root 2 is getting multiplied with minus 1, so it becomes minus 1 by root 2. So you can find that this is the whole thing, and this kind of solution is expected from you, and things are very simple. Okay, if they're asking theory question on 8-point DIT FFT, if they're asking numericals directly, you can solve it, and you can check that x1 and x7 they are complex conjugates, x2 and x6 they are complex conjugate, x3 and x5 they are complex conjugate, x0 is nothing but addition of all the terms in xn, and x4 is nothing but alternate plus minus of all the terms in xn. So the result should be validated like this. So just after finding x0 to x7, that is capital X0 to capital X7, you yourself can come to know whether the answers are correct or not. Let us have, so this is the last slide. Let us have an analysis of what all we have done in the 8-point DIT FFT. Okay, so we have taken a very simple kind of a sequence. We are not finding it at all difficult to find what is the output. But yes, if the sequences are little clumsy, like 1, 2, 3, 4, 5, 6, 7, 8, if I give you, then these values will become bigger. Okay, nothing else, but this pattern will remain same. What is the pattern? That is the first thing, whatever x0 you are finding is nothing but addition of all the components. So if I give you 1, 2, 3, 4, 5, 6, 7, 8, in that case, just keep on adding 1, 2, 3, 4, 5, 6, 7, 8. Whatever you get here, that will be nothing but your capital X0. And then 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8. That will be your X4. The same thing which is happening here. So the analysis, first component, that is capital X0, is nothing but addition of all the things. That is the DC component. Next, you are finding that x3 and x5, whatever you have found, they are complex conjugates. And x1 and x7, whatever you have found, are complex conjugates. And x2 and x6, whatever you have found, they are also complex conjugates. So don't worry much. You just keep on calculating, and after calculation, you check the results. If this kind of patterns, if you find, means your answer is correct. And lastly, what is x4? X4 is the central component. That is nothing but 1 minus 0 plus 0 minus 1, and likewise you keep on doing, and it becomes 0. Now some question I can ask you. I'll just give you xn as 1001. I'm not going to give you xn of length 8. I'll give you xn of length 4, 1001. Okay, and I'll ask you to find out a 8-point DIT FFT. So what is the first step? You have to pad this 40. So 1001 0000. So whatever is the sequence given, you first have to make it 8-point. Maybe I can give you a 6-point sequence or 5-point sequence. So first thing you have to do is you have to keep on padding 0 and to make it more like a radix 2. So what is radix 2 here? So 2 point, 4 point, 8 point, they are radix 2 DIT FFT. Okay, so first you have to make it either 2 raised to 1 or 2 raised to 2 or 2 raised to 3. So if I give you 5-point xn, first you have to make it 2 raised to 3. Okay, that is the closest radix to DFT or FFT you can find, and then you have to perform what is DIT and FFT. Same thing happens in case of matrix. So if an image is given, so you are learning all these things so that you can find out the FFT of image given. You want to find out what are the frequency components of that image. So in that case, x direction, y direction, in both the direction, you might have to pad a lot of zeros to make it a power of 2. So number of intensities that you are having every line, that you have to pad towards the end of x-axis and y-axis. You have to pad 0, and you have to make the image kind of a matrix, and then only you can apply radix 2 FFT for that. Okay, so I can give you 1001, and I can ask you to find a 8-point DIT FFT. But first step you have to do is you have to pad 4 zeros, and then you can make the sequence xn as 8-point, and then you can find the same FFT, and you'll be getting the results. And what to understand? So one homework I'll be giving you. Already we have seen what is the amplitude plot and phase plot, and these are not the final answers. So final answers can be found out from here. So x0 is 2, and there is no imaginary part, so angle is 0. Here 1 minus 1 by root 2 minus j by root 2. So if you are converting them into polar plot, you'll be finding x1 is coming to be 0.7653 and angle is minus 67.5. And x1 and x7, they are complex conjugate. So if x1 is 0.7653, x7 also will be 0.7653. Only difference will come in angle, because amplitude is a even spectra and angle is a odd spectra. Odd spectra means x1 and x7, they will be in opposite sign. So x1 is minus 67.5, x7 will be plus 67.5, whereas amplitude for them are same, 0.7653. Same thing happens in case of x2 and x6. So x2 is 1.414, that is 1 plus 1, that is root 2. Amplitude of this will be root 2. Root 2 is nothing but 1.414. And you can find out 1 plus 1j, that is tan inverse of 1, that is nothing but of 45 degree. But 1 minus j means this is in the fourth quadrant. Okay, this is in the fourth quadrant because x-axis is positive, y-axis is negative. So there is the fourth quadrant. So fourth quadrant means angle will become minus. So this has become minus 45 degree. So you can check here x2 and x6 both are having same amplitudes, that is 1 plus 1j. Here it is 1 minus 1j. If you want to find out amplitude here, this will be root under of 1 square plus of minus 1 square. That means again the amplitude will become root 2, that is 1.414. So here for 1 plus j, angle is 45 degree. For 1 minus j, angle is minus 45 degree. And finally x3. So x3 is 1 plus 1 by root 2 minus j by root 2. If you are just converting them into a plus jb form first and then into r theta form, you'll be finding this is 1.847 angle minus 22.7. And x3 and x5, they are complex conjugate. So x5, you'll be finding the amplitude is same, 1.847, and angle is plus 22.5 degree. So what you are supposed to do is you have seen this kind of plots previously. Okay, we have shown the plots in case of 4-point DFT. So I think long back it was done. So this is the kind of a plot that you're supposed to do. But in this case, only instead of k is equal to 0, 1, 2, 3, you have to extend it up to k is equal to 0, 1, 2, 3, 4, 5, 6, 7. And you'll be finding that this first thing will be 2. And after that, 1, 2, 3, 4, 5, 6, 7, odd number, they will be exactly in the symmetrical form. And here also k is equal to 0, so DC component is having, in this case also DC component is having no angle, so this will be again 0. But the 7 components whichever is coming, again x4 also will become 0. Okay, so x1 x2 x1 x2 x3 and x5 x6 x7, they will be in a odd format. So this is the phase plot and this is the amplitude plot. This you have to do, and I am leaving that thing as a homework to you. So I have done the 8-point DIT FFT, and the results are found, results are matching, and they're complying it to whatever understanding we have developed so far. That is, if there is 8-point FFT, there will be 8 different results. In that, x0 will be the DC component, x1 x7 will be complex conjugate, x2 x6 will be complex conjugate, x3 x5 will be complex conjugate, and if plotted, all the amplitude plots will produce a even spectra and all the phase plot will produce a odd spectrum. So I'm leaving this homework to you, and next day we will do some 1 or 2 more numerical on 8-point DIT FFT, and then we will see 4-point inverse DIT FFT algorithm. And finally the topic of this main topic of this chapter, there is a spectral analysis of FFT that we will do in the next sessions. So only 3 topics remain.